So in this problem, we want to go about graphing the function f of x equals negative 3 sine of 2x minus pi plus 1 over 2 periods. So whenever it says over more than one period, that just means we're going to do our standard graphing method, and then we're just going to transpose one more period onto it. So the first thing that we need to start off with is setting what's inside of our trig function between one period. So remember, because we're dealing with sine, or if we were dealing with cosine, we take what's inside of here, the 2x minus pi, and we set that less than or equal to 2 pi, but greater than or equal to 0. This represents one period, but since we're not dealing with x, we're dealing with 2x minus pi, we need to find where one period will lie in this graph instead of 0 to 2 pi. So we're going to start by adding pi to all three of these, which gives us pi is less than or equal to 2x, which is less than or equal to 3 pi. And now we'll divide everything by 2 to get rid of the 2 that's in front of our x. So we get pi over 2 is less than or equal to x, which is less than or equal to 3 pi over 2. So now we know that one period of our graph will lie between pi over 2 and 3 pi over 2 instead of 0 to 2 pi like the standard parent function of sine. So it's at this point that we now need to find our period. Remember, your period given sine or cosine is p equals 2 pi over b, which in this case b is this 2. B is always the number that's multiplied to your x. So we get 2 pi over 2. So p equals pi. One period of our graph is equal to pi. Now we need to find p divided by 4. Remember, we always work with our quadrantal angles when we're graphing. They're the easiest values. So finding p over 4 will help us find all of our quadrantal angles. This is how far apart they'll be. So we get p is pi divided by 4. So our quadrantal angles start at this pi over 2, they finish at this 3 pi over 2, and they're a distance of pi over 4 apart. So we need to make our table at this point to find all of the x values of our quadrantal angles. So we start with our pi over 2. And remember, this is our x, and this is our sine of 2x minus pi. Remember, this isn't our entire function f of x. This is only taking into account our horizontal transformations. So again, we start at this pi over 2, and now we're going to add pi over 4 to it. Pi over 2 plus pi over 4 gives us 3 pi over 4. And now we're going to repeat this 4 times. If we add p over 4 4 times, it's as if we added one period of our graph. So we add pi over 4 to 3 pi over 4. That gives us just pi. We add pi over 4 to this again. We get 5 pi over 4. And finally, we add pi over 4 to this again, which gives us 3 pi over 2. It gives us 6 pi over 4, which we reduce to 3 pi over 2. And we can do a quick check to make sure we've done this properly. Our table starts with pi over 2, it ends with 3 pi over 2, just like our inequality over here. So that means we've done this properly. Now, we could go about plugging in all of these values into sine of 2x minus pi, and then find their unit circle values. But we don't have to do that. Remember, these represent our new quadrantal angles. So these values will always be the quadrantal angle values, meaning we start with 0, 1, 0, -1, 0 when we're dealing with sine. Remember, this will always be true if you've done this properly. And we could do a quick check. If we plugged in pi over 2 in for x here, we would end up getting sine of 2 times pi over 2 is just pi minus this pi. And pi minus pi simplifies down to 0. So sine of 0 is 0, which confirms what we have here. Instead of going through this process 5 times, we can always just memorize these values. Okay, so that's going to give us our period, one period of our graph. Now, our last step is to list all of our vertical transformations and then finally graph them. So, going to our list of transformations, the first one that we have is this negative that's being multiplied in front of our sine. Remember, whenever you have a negative multiplied on the outside of your function, that means you're dealing with a vertical reflection. From there, because of the 3 that's being multiplied, 3 is greater than 1. That means we have a vertical stretch. If it were between 0 and 1, for instance 1/3 or 3/4, then this would have been a vertical shrink or compression. And finally, we have a +1 here. That means that our graph is getting shifted up 1. So these are the 3 transformations we need to take care of after we graph our standard function over one period. So we'll get to graphing this. We have the point pi over 2, 0. So we first need to label our graph before we can start actually plugging these values in. So we need our graph to go from pi over 2 to 3 pi over 2. So if we were to say that this were pi over 4, then this would be pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. So these tick marks are enough to do one period of our graph. We'll just label this as 3 pi over 2 and this as pi over 4, just to give a general idea of what each of these tick marks means. So this pi over 4 tells us that a tick mark means a distance of pi over 4, and then this last one tells us that our final tick mark is a distance of 3 pi over 2. So at pi over 2 comma 0, we have a point. Then at 3 pi over 4 comma 1, we have a point. Pi comma 0, we have another point. 5 pi over 4 negative 1, we have a point. And finally, 3 pi over 2, 0, we have our last point. So if we connect these dots with a general curve, remember it's not straight lines, we get one period of our base function essentially. Now we have to go through performing each of our transformations to get our final graph. So I'm going to choose a different color here. So the first thing that we have is a vertical reflection, which means anything above the x-axis will flip below it, and anything below it will flip above it. So this point is going to stay right where it is. This point at the top of this hill is going to come down as a valley. Again, this point will stay where it is. This valley will become a hill. And finally, this point will stay where it is again, giving us a new graph that looks like this. Now we have two more transformations to take care of. Again, I'll pick a different color. Let's try green in this case to take care of our vertical stretch. So remember, our vertical stretch is by a factor of 3. That means every y value is going to be multiplied by 3. So this point, if you multiply the y value by 3, 0 times 3 is still 0, so it's going to stay right where it is. But this valley is now going to go from -1 down to -3. -1 times 3 will give us -3. So this point is now here. This point on the x-axis will again stay where it is. This hill will go from +1 to +3 when we multiply it by 3, which gives us a new point up here from where we started. And finally, this value on the x-axis will again stay where it is, giving us a graph that looks like this. I'm doing my best to sketch this out, but obviously it looks a little bit more distorted than it should. This line should be a little further to the left. Okay, and now we have one last transformation to take care of, and it's that up 1. So we're going to take this entire green graph and shift it all up a value of 1 on the y-axis. So my final graph is going to be in blue. So this point in green is now going to move up 1 here. This valley is going to move up 1 to here. This green point will again move up 1. This hill will move up 1. And finally, this green point will also move up 1, giving us a final graph that looks like that. But remember, we were told to graph over 2 periods, which literally means we're going to take this entire graph and shift it over a distance of pi. Why a distance of pi? Because we said our period over here is a value of pi, which means the graph repeats every time you travel a distance of pi. So if we, for instance, take this point here all the way to the right of our graph and move a distance of pi to the left, we'll have the exact same y value we started with, which gets us to the end of our graph on the left. Now let's do the same thing with this this hill up here. This hill is going to move a distance of pi to the left. So that's 1, 2, 3, 4 tick marks to the left. It'll be about here. This point here in the middle will also move 4 tick marks to the left. We have 1, 2, 3, 4. This valley will move 4 to the left. 1, 2, 3, 4. And finally, this last point on the left will move 4 to the left. 1, 2, 3, 4. Note that we're moving 4 to the left because each of these points is a distance of pi over 4. So if you move 4 units of pi over 4, it's as if you moved a distance of pi. That's 1 period on this graph. And now we'll just connect our dots again to get 2 periods of our graph look exactly like so in the blue. And now we just want to label this f of x. Now go ahead and try this problem out, and I'm going to make a separate video that'll cover this.